So we have a couple of different types of mutations that are really important to know. So we have silent mutations where we end up coding for the same amino acid. And this would be the best type of mutation to have because you're not going to change the protein at all because you end up coding for the same amino acid. So nothing changes. A missense mutation is where you end up coding for a different amino acid. And this may or may not change the protein depending on what amino acid it gets changed to and where the amino acid is in the protein. So it may or may not cause problems. And then a nonsense mutation, this is where the mutation ends up coding for a stop codon. So you stop making the protein way too soon. And that's the worst type of mutation to have because you're going to be missing probably a big chunk of the protein, and if it's not there, then the protein's not going to be able to do its job. So that's the worst type of mutation to have. And then the other type of mutation are these frame shift mutations. So these are caused by insertions or deletions of nucleotides in the DNA. And so what happens is we end up shifting the reading frame of the codons in the messenger RNA, the groupings of 3, and so that'll end up causing missense or nonsense. So let's just take a look at some pictures of these mutations. Okay, so what I could do on the test is I could either have you identify these types of mutations by either a definition, or I could give you a picture where you have the normal sequence given up here on the top, and then I'll give you the abnormal down here on the bottom, and you've got to figure out, well, what kind of mutation is this? So what we're looking at here on the top, up here where we've got the normal, what it should be is we've got the double-stranded DNA in the blue, and then the messenger RNA that's been transcribed here in red. And then we've translated the messenger RNA, and here's our protein here on the bottom. So the way that you look at these and try to decide what kind of mutation this is you really just need to look at the amino acids and compare this one on the bottom that we've got a problem with, and then compare that one to the top that's normal. And so in comparing the one on the top here to the one on the bottom, you notice that the amino acid sequence is the same. So that means that this is a silent mutation because we end up coding for the same exact amino acid, so there's no change at all. So even though you can see that we've got a change in the messenger RNA codon here, we've got GGU instead of GGC, we end up coding for the same exact amino acid glycine. So this would be a silent mutation. Okay, so we end up coding for the same exact amino acid. All right, let's look at our next one. So if I take a look at the top amino acid sequence and then I look at the bottom, you can see that this last amino acid serine is different from the normal glycine. So coding for a different amino acid would make this a missense mutation. Okay, so a missense mutation, you end up coding for a different amino acid. And that may or may not affect the function of the protein depending on which amino acid you ended up putting in the protein and where it's located in the protein. Okay, this next one, you can see that there are definite problems here. So here's our normal up here on top. And on the bottom, you can see that our mutation has caused a stop codon where there shouldn't be one. So this is a nonsense mutation where we end up having a stop codon where there shouldn't be one. And so we end up stopping making the protein way too soon. So this would be the worst of the mutations to have because we're missing a lot of the protein, and so it's not going to be able to do its job. All right, so this next one that we have here, if we take a look at our DNA, notice that we've got an extra base pair that's been inserted. So we've got an AT, and that means there's an extra U in the messenger RNA, and this is a frame shift mutation. So we're going to shift our reading frame. So our groupings of 3 that are going to be coding for our amino acids, we're going to shift that. And so up here on the top, we had our start codon AUG coding for the amino acid methionine. And then we had AAG coding for lysine, but down here you can see that AUG, and then we grab our next grouping of 3, we've got UAA, because we've got that extra U in there. And unfortunately, that's a stop codon. So this frame shift ends up causing a nonsense mutation. Okay, so insertions and deletions in the DNA will cause these frame shift mutations, which will end up causing nonsense. Or here we've got a deletion in the DNA where there's an AT that's missing in the DNA. So now we've got a U that's missing in our DNA. And then if we go up here, you can see that in our messenger RNA, we should have 3 U's together coding for phenylalanine. But if we go down here, there's a missing U, so we just grab the next letter, and so we've got UUG. And so that codes for leucine instead of phenylalanine. And then we grab our next grouping of 3, we've got GCU, and so now that one's messed up too. We've got alanine instead of glycine. So we end up coding for the wrong amino acid. So now we've got this frame shift mutation causing a missense mutation. Okay, so anytime you have insertions or deletions in the DNA, you can end up with these frame shift mutations, which could cause nonsense or missense.